This presentation demonstrates the correct handling of the Straumann dental implant system, focusing on the Straumann standard implant line. The Straumann dental implant system offers 5 implant lines with diverse body and neck designs, ranging from the tissue to the bone-level implant. All implants can be inserted with one surgical kit and require very similar surgical procedures. Straumann standard implants have a smooth neck section of 2.8 millimeters. They are especially suitable for single-stage procedures where the implant is placed at the soft tissue level, but is not covered with soft tissue during the healing process. There are 4 different versions of standard implants: 3.3 millimeters, 4.1 millimeters, and 4.8 millimeters for the regular neck, and 4.8 millimeters for the wide neck. They are available in 6 different lengths, from 6 millimeters to 16 millimeters. Preparation includes 2 main steps. First is basic implant bed preparation. This step involves ridge preparation and twist drilling. The second step is fine implant bed preparation. This includes tapping. After opening the gingiva, the basic implant bed preparation begins by carefully reducing and smoothing a narrow tapering ridge with a large round burr at a maximum speed of 800 RPM. The goal is to provide a flat bone surface with a sufficiently wide area of bone. When choosing the implant length, the vertical dimension of the bone has to be considered. The implantation site, which was determined during pre-operative implant position planning, is then marked with the 1.4 millimeter round burr. The implant distance indicator can be used for this purpose. The position of the mark is widened and corrected using the 2.3 millimeter or the 3.1 millimeter round burr, if necessary at 800 RPM maximum. The implant axis is marked with the 2.2 millimeter pilot drill to a depth of about 6 millimeters. The short side of the 2.8 millimeter depth gauge is inserted with the distance indicator to check for correct implant axis orientation. The implant bed is pre-drilled to the final preparation depth with the 2.2 millimeter pilot drill. Next, the 2.2 millimeter alignment pin is used to verify the implant axis and preparation depth. At this point, an X-ray should be taken, particularly with vertically reduced bone availability. The alignment pin is introduced into the drilled area, which allows the drill hole to be visualized in the context of the anatomical structures. If necessary, the implant position can be corrected with the 2.8 millimeter pilot drill. The 2.8 millimeter depth gauge with the longer side should be used to measure the depth. This is where basic preparation ends for the implant with an industrial diameter of 3.3 millimeters. But for 4.1 and 4.8 millimeter implants, preliminary work continues with the 3.5 millimeter Straumann Twist Drill Pro. The 3.5 millimeter depth gauge helps to check the final preparation depth. It's here that basic preparation ends for an implant with an industrial diameter of 4.1 millimeters. Fine implant bed preparation is next. For 4.8 millimeter implants, the 4.2 millimeter Straumann Twist Drill Pro now is required. The final preparation depth is confirmed with the 4.2 millimeter depth gauge. Tapping is needed to prepare the implant bed for specific thread types. This is an optional step that provides the flexibility to adjust the surgical protocol to the bone class, and consequently, to achieve optimal primary stability. It is recommended in dense bone and with large diameter implants. Tapping should be used in the coronal area only, or to the full depth of the implant bed, depending on implant diameter and bone class. To prepare the ratchet for tapping, a ratchet adapter has to be connected to the tap for adapter. The standard tap is inserted into the cavity, and the ratchet is placed on its coupling. The clockwise arrow on the knob indicates the direction of insertion. The thread is tapped with a slow, rotating movement. The direction of the ratchet is changed so that the arrow on the knob points counterclockwise. The holding key functions as a stabilizer to maintain the direction of tapping. For tapping with the handpiece, the tap for adapter is connected to the handpiece through the handpiece adapter. The entire length of the implant bed should be pre-tapped with the standard tap at 15 RPM maximum and in accordance with the bone class and endosteal diameter. For a Straumann SL active implant, the blister is opened and the vial is removed. The blister ensures the sterility of the implant. It should not be opened until immediately before implant placement. The implant carrier is detached from the lid by pulling it off by hand. After removing the implant from the solution, the chemical activity of the SL active surface is ensured for 15 minutes. A Straumann implant can be placed either manually with the ratchet or with the aid of the handpiece. The implant carrier should be held at the closed end. The adapter then is pushed onto the implant until there's a click. The implant carrier is pulled slightly downward to remove the implant from the implant carrier. At the same time, the implant is lifted from the carrier with a slight twist. The implant is placed manually into the implant bed with the aid of the adapter. One option for positioning the implant is to use the ratchet attached to the pivot of the holding key that functions as a stabilizer. The clockwise arrow on the knob indicates the direction of insertion. The implant is then brought into its final position by slowly manipulating the ratchet. The direction of the ratchet is changed so that the arrow on the knob points counterclockwise. The holding key is used to counter the hexagon and loosen the transfer part counterclockwise with the ratchet. The holding key is removed, followed by the ratchet, while the adapter is held at the bottom. Finally, the transfer part is removed from the implant. The adapter is still completely mounted. Another option is to use the handpiece to insert the implant. The implant carrier should be held at its closed end, and the handpiece adapter pushed onto the implant until there's a click. Simultaneously, the implant carrier is pulled down and the implant is lifted out of the implant carrier. The implant is placed with the handpiece into the implant bed. Then the implant is moved to its final position by turning it clockwise at a maximum speed of 15 RPM. When the floor of the bone cavity is reached, there's a perceptible increase in resistance. Before the transfer part is removed, the motor is set to reverse. During the first few turns, the transfer part should be held firmly with the holding key that is stabilizing the hexagon. The transfer part is then removed. For submucosal healing, it is recommended to use a closure screw or a short healing abutment. Before the closure screw is inserted following the first surgery, the internal configuration of the implant must be clean and bloodless. The SCS screwdriver is used to pick up the closure screw. The friction fit secures the closure screw to the screwdriver during insertion, thus assuring safe handling. The closure screw is tightened by hand. The mucoperiosteal flaps must be adapted carefully and sutured together with interrupted sutures. The result should be a tight seal over the implant. Before mounting a healing abutment, the internal configuration of the implant must be clean and bloodless. The abutment is mounted using the SCS screwdriver. The friction fit secures the components to the screwdriver during insertion for safe handling. The healing abutment is tightened by hand. The soft tissue is adapted and resutured tightly around the abutment.